I'm really excited about this talk today, specifically because last year I had to spend most of my talk explaining why launch is important. And I think everyone's done that really well over the last year. That's been articulated quite well. So I can spend my time today talking about what I think is most important, is how we're going to actually get this done. Like I said in the beginning, we're just at the starting line. This is not the finish line. So, when I look at an image like this is what I think about when I think about launch in Canada and what we should be aspiring to in the next 2 or 3 years. People often like to think about SpaceX and Falcon 9 and these giant rockets and massive scaled operations, but the first step for us is to get a light lift vehicle to orbit. 20 years ago, almost exactly, SpaceX launched Falcon 1 for the first time to low Earth orbit. Almost 10 years after that, Rocket Lab launched Electron to low Earth orbit. And since then, really, these are the only two companies that have scaled launch. And I think we want more Rocket Labs and SpaceXs in Canada, and not the other guys. So how did they get to orbit, and how much did it cost? Well, SpaceX and Rocket Lab, coincidentally, not only built their launch vehicles for about $100 million US, but also built the infrastructure and built companies that have now turned into billion-dollar, and in some cases possibly trillion-dollar companies in the span of just 2 decades. You look at a chart like this, and it makes you wonder what the correlation really is, and what are the other factors that contribute to a successful orbital launch system in Canada. You have companies that have reached orbit but haven't scaled. You have companies that have spent way more than that and have failed completely, and you have others who have yet to reach orbit and are spending multiple factors more than what SpaceX and Rocket Lab did. So what exactly did they do differently? And this is the question when I started NordSpace years ago, I set out to answer with this company and make sure we're drawing in the right lessons to build what they did here in Canada. So the first question that really we have to ask ourselves when we look at a company like SpaceX is SpaceX really even a rocket company? 70% of SpaceX's launches, Falcon 9 launches, are Starlink and growing. Starlink generated $11.5 billion of their revenue. That's 65% of SpaceX revenue. External customers pay $75 million for a Falcon 9 roughly now. SpaceX internally, $28 million. They've been able to figure out how to internalize the economics of launch. I suggest to you that SpaceX is effectively a space telecommunications company masquerading as a rocket launch company. But that rocket launch component is extremely important. How about Rocket Lab? Is Rocket Lab really a rocket company? I mean, you have rocket in their name. Rocket Lab, Space Systems Division, generated $600 million. 70% of the company's total revenue and launch was only about 30%. Approximately 60% of Rocket Lab's launches contain satellites and contain Rocket Lab hardware. Rocket Lab's contract backlog is almost $2 billion, of which 75% is space systems. Does that mean that they should abandon rocketry? Absolutely not. But does that mean that they're a rocket company, or are they a space missions company, which is exactly what they call themselves? Absolutely yes. Here you see the Escapade satellites that went to Mars. Vertical integration is the key. And at NordSpace, we're waging war on the idea of vertical integration and taking it to an absolute extreme over the next decade so that we build a sustainable launch company, a sovereign launch company that can power a sovereign launch capability for Canada. Our hypothesis and thesis really is that you can't have sovereign launch in Canada unless you have a sovereign launch company. And that goes throughout the whole stack, from the technology to what goes on top of the rockets, to where the rockets launch from, to how they're funded, and everything in between. So the question really isn't, why are you vertically integrating? What we ask ourselves is, why aren't you vertically integrating enough? And we've often walked back on certain things that we thought we would vertically integrate and realized we shouldn't. But the key for us, and I think for Canada, is to realize that launch is a means to an end. It's the moat, it's not the castle. So what is the castle? At NordSpace, we have 3 divisions, primarily. We have launch, really 2, launch and space systems. These are almost separate companies. Launch takes up about 80% of our company's resources, time, personnel. Space systems, 20%. Although they operate separately, the integration and them operating under the same roof is incredibly important. At the same time, we have not decoupled the infrastructure that actually powers our launch program. So we're building our own spaceport, and there's a lot of reasons why we chose that route. And of course, everything is colored with a dual-use defense lens as well. But NordSpace's divisions, beyond just providing this end-to-end space missions capability that can get us to a point that Rocket Lab and SpaceX did and make Canada a true sovereign spacefaring nation, is what we can do for the rest of the world. Us, being friendly Canadians, can package and box up an end-to-end space missions capability, and we believe over the decades ahead, many other countries who do not have the same institutional knowledge or supply chains and capabilities will also realize how important sovereign space is, and Canada can power the sovereign space capabilities for the rest of the world. Our company's goals are split up into 3 phases over the next 10 years. Phase 1 is pathfinder missions that are self-funded, and that's what we've been doing for many years already. We're deploying our own technology and our own finances in experimental rocket development, satellite development, robotics, manufacturing, and everything else. We've been doing this for years. Decidedly, we're a product company. We're not a contracting company. We build products that mean something and then go from there. These Pathfinder missions will inform real data in orbit, real space experience. How do we expect to launch customer payloads on our rockets if we don't understand their experience as it exists right now? So I'll talk about what we're doing on that front. Phase 2 is about scaling our space systems division and, of course, advancing launch through Launch the North, Phase 2 and Phase 3, hopefully, and everything else in between, but deploying our small satellite platforms at scale for hosted payloads and small constellations. Revenue and market penetration become a baseline for us. I totally believe in all the different funding mechanisms that can power a company like ours, but as somebody who's built businesses before, there's really only one thing that I know matters, and that's generating revenue and turning that into profit. We have to be a real business in order for this to be scalable and sustainable. And when Tundra is finally ready to launch, Phase 3 officially begins, where we converge our space systems and rocket sides together and create so much internal demand and cadence, deploy our own constellations, and basically have a cost structure that nobody else can compete with other than vertically integrated companies. This is an ambitious future, but there's historical precedent for it, recent historical precedent for it, and it's up to us to choose this path or not. So here's a glimpse of what the future we're building at NordSpace will look like over the next couple of years. Thank you. So how do we make that future a reality is what I'm hoping to convince you all of right now, where you can draw a straight line from where we're at today to that future. So our launch vehicles, there's 3 of them that we are developing at varying stages. Our focus is really on our light lift vehicle right now, but we have our Taiga suborbital launch vehicle, an amazing pathfinder system that we're building to basically build confidence, launch cadence, operational excellence, and experience that translates into our hypersonic test platform, but also transfers into a 3rd stage vehicle for Tundra. Orbital vehicles are Tundra and Titan. In 2028 is when we expect Tundra to be capable of performing its first mission in its optimized format, 1,100 kilograms to low Earth orbit, and a combination of several of our Hadfield 150 engines and Titan is a future that we think is extremely important, which is our medium lift future. 5 tons minimum to low Earth orbit, a partially reusable launch vehicle. So the Hadfield engine is really the crown jewel of our entire launch program at the moment. This is an amazing engine capability that we've been refining over many years of design iteration and testing. And we're getting to a point now where we're turning basically engineering models and experiences from our suborbital scale vehicles into real orbital scale engine hardware. As of this week, in fact, our engine is officially patent pending, which is quite exciting. And for the first time, we've publicly put on display our Hadfield engine at our booth. So there's a lot going on behind the scenes of why we chose an engine design like this, and of course it'll evolve over time, but we're really trying to optimize not just for performance and scale, but for cost, for speed, for testing infrastructure, for forgiveness, even in our launch program, where if we lose an engine, can we still make it to orbit? Yes, we can. So things like these matter. Here's what it looks like at our facility to produce one of our engines and then take them to our test site to fire them. We 3D print all our engines in-house, post-process them, and take them to Area 66. None of this existed when I was on stage last year, exactly a year ago. Pretty much anything I'm talking about today didn't exist a year ago. So hopefully it gives you a sense of how fast progress can be when you have a dedicated and serious team. But we're expanding that site over the next couple of months to now support our orbital engine development. Our engineering models are turning into real manufactured parts. Combustion chambers, turbopump assemblies, and everything else will be tested at a rapid pace. But of course, advanced manufacturing is central to what we do. If we want sovereign launch, if we want vertical integration, you can't have sovereign launch without sovereign manufacturing. So a couple of months ago, we officially established what we call the AMA Lab, the Advanced Manufacturing for Aerospace Lab, and we're scaling this big time now. The 2 key areas that we're working on primarily are additive manufacturing and robotic composite manufacturing. So we're going to be developing full flight scale hardware and structures, primary structures, tanks, interstages, fairings, and everything in between over the course of the next couple of months. By bringing in robotic systems like automated fiber placement and other really advanced systems, we actually have one of our very early prototypes for our fairing on display at our booth as well. That'll give you a sense of the scale of the vehicle that we're building even at the light lift scale. Now, a lot of this is supported in collaboration with partners like the National Research Council of Canada, Fraunhofer Institute in Germany, and Engine. Now, how do we do this at scale? You need a really big space. So this week, we officially moved into our new NordSpace campus. This facility will allow us to scale to at least 230 people, allow us to put out at least 10 satellites at any given period, and 2 orbital launch vehicles at the light lift scale. So the NordSpace campus is now going to be outfitted with all the advanced manufacturing capabilities, the offices, and of course, the people that'll actually make all of this happen. So we couldn't be more excited about this move, especially because we're crammed like sardines where we are right now. Another really big piece to make all of this possible, again, looking at the Rocket Lab and the SpaceX story, is vertically integrating the infrastructure. You look at this every way you possibly can, and there's really no clear way to decouple the critically important infrastructure that goes beneath the rocket as well, whether it's test facilities or launch facilities. So Last year, we introduced the Atlantic Spaceport Complex as a high-level idea to you. Months later, we started construction in Newfoundland and Labrador. We achieved our environmental approval in record pace with some of the greatest conditions, fulfilling them now. And here's what construction looks like at the Slick 2 at the ASX. So not only is it an absolutely gorgeous site, but it's spread out over two sites. Slick 1 and Slick 2, what you see here. Slick 2 is for suborbital space launch style missions, and Slick 1 is where we'll be building at least 2 orbital paths to start for light lift. The great thing about this site specifically is it gives us tremendous amount of scalability. We chose this site not just for light lift, but thinking about our medium lift future and potentially a heavy lift future years after that. The ability to expand out to 10 kilometers, 15 kilometers out, and still maintain the right safety distances and inclinations is extremely important for us. So this launch site offers the widest range of launch inclinations, nominal launch inclinations in all of Canada, largest safety distances in all of Canada, approved for the greatest number of launches from our EA in Canada, and purpose-built for NordSpace. We're not hunting for a rocket. Of course, we'll happily accommodate friendly nations and their launch vehicles when the fit is right. We have great partners that we're leaning on that didn't exist for us even a year ago. Kongsberg Geospatial, somewhere here as well, working with us on mission operations and range safety. We have Seacor, another Newfoundland-based organization, working on SATCOM and ground capabilities. And Leo Labs, I believe here as well. We're looking forward to developing an SDA capability on the ground on the Atlantic coast over the next couple of years. So late last year, we went out for our first launch campaign. And although Taiga didn't launch and we learned some incredible lessons, we're going to be back on the pad very soon and complete that mission. Our team is completely focused right now on our orbital mission. Really taught us how intense launch campaigns are, even at smaller rocket scales. But just getting a launch vehicle integrated on the pad, tested, and ready for flight was an incredible experience for us, and we're looking forward to completing that mission very soon. So let's talk about space systems. What are we doing on the space system side? The parts that go on top of the rocket. It's a small but mighty team at NordSpace where we have several missions coming up. We're starting with Terra Nova. Terra Nova is our first Pathfinder satellite, where we're developing the bus and core payload capabilities that will actually enable our future in Phase 2. Terra Nova is launching on Transporter 18 later this year. We've been working around the clock over the last several months to prepare the satellite for launch. It consists of 2 payloads that we developed in-house. Chronos is a real-time intelligence Earth observation system consisting of 3 cameras with an NVIDIA GPU on the back of it. We're using the system to conduct Pathfinder tests for wildfire monitoring with real-time intelligence, as well as Arctic monitoring. We have Zephyr EP, a small in-space propulsion thruster that we've developed, leaning into our propulsion experience. You see a little bit of the cross-pollination between our rocket and satellite side to provide capabilities for deorbiting and other types of missions. The Terra Nova platform will be scaled significantly. You can see here Tim and David, 2 of our space systems engineers, holding Chronos in its completed form for the first version, and our first Terra Nova satellite in our clean room. At NordSpace, we're building this in-house. We're testing it in-house with our own TVAC, thermal, vibe, clean rooms, and everything else. The constellation and hosted payload feature that we're looking to enable in Phase 2 as we exit 2026 is going to be powered specifically by this capability. We're going to be working on satellites in the class of 10 to 100 kilograms and be able to provide a lot of the capabilities that we believe Canada desperately needs. We believe in and agree with the whole build, partner, and buy framework to develop these capabilities. I'm extremely proud of how far we've come. Now, last year on stage, we have Andrew Ronan, there he is. He put a challenge out, little did he know what was actually going on behind the scenes at NordSpace. He said, let's launch a Canadian rover to the moon from Canadian soil. We've always been big believers in our lunar future, and the last couple of months have only emphasized that further. We believe what CubeSats and everything else has happened in LEO, opportunity that maybe Canada missed out on to own that space, we can own it on the moon. Behind the scenes, we've had 2 engineers working around the clock again on our lunar program, which consists of 3 missions over the next couple of years and 2 payloads going to the surface of the moon next year. The first mission is Terry, a little rover. It'll be the first Canadian lunar rover on the surface of the moon. It'll make us only the 5th nation to have a rover on the surface of the moon. It'll serve as a pathfinder, a test for what's to come. Think of this as the 1U CubeSat equivalent of a lunar rover on the surface of the moon. It's already manifested, and it's going to the moon, and nothing's stopping us. This is a completely, like Terra Nova, privately funded mission. And think of it as our skunk works, beaver works, if you were, side of NordSpace, where we work on things that matter on our own dime. How are we going to scale Terry, which is the name of this rover, honoring Terry Fox's legacy and extending it to the moon? With a program called LTAP. We're designing this program such that we create a slightly larger version of Terry, which is now unveiled at our booth, where we're going to be producing flight-grade versions of Terry and sending them out to universities and companies to treat as a platform on which they can bolt on their payloads and get reliable access to the surface of the moon. So LTAP is starting later next year, and again, squirreled away in a small part of NordSpace's larger campus. We're very excited about the lunar future that this will enable, and the type of ambition that I think Elliot was hinting at, where we want to bring the types of people back to Canada that are working on a big mission with a big vision. More on that in a moment. Here's a quick little video to show you what Terry is going to look like as it approaches the surface of the moon. Hopefully this captures the ethos and the culture at NordSpace. We don't wait for permission, we just build. So how did we get this far, and how did we develop this culture at NordSpace? Among all the technical ambition and the future vision and the patriotism, there's strategic pieces that we move on the chessboard every single day to put us in a position where we will be successful. Private capital has played an immense role. My own story is I built businesses before NordSpace with the express goal to be able to invest into NordSpace and not have to ask anybody for permission. Work on missions and systems with long-term value, not venture capitalists who are looking to just nudge you to raise the next round and looking for liquidity. We're investing in ourselves. I started with a $10 million investment and another 10, and my goal is to commit $50 million over the next several years to our launch effort. This will allow us to maintain a 100% Canadian-owned company that'll scale, that'll stay sovereign, and allow us to grow and continue at this pace with larger and larger missions, so that missions like Alex McDonald's interplanetary mission is something that we can actually take on because we have the right stuff. But it's not just about investing in ourselves. Bringing private capital into the rest of the space and defense industry across Canada is just as important. We're not going to do anything in space and with launch if there aren't enough payloads to get us there. So NordSpace Ventures is something that we started last summer with the intent to start investing in Canadian space and defense companies, in particular space companies. We announced a couple of months ago our first investment in Wyvern, and we have had several more. Wyvern's a great hyperspectral imaging company, and we're looking very forward to scaling with them. At the same time now, we're excited to announce 2 additional companies that we've invested in, with several more to follow. The first one is Volta Space Technologies, working on wireless power systems from the surface of the moon to lunar orbit, and even in LEO and deep space. We're very excited about integrating their technologies into our path forward in lunar exploration. We're also very excited to be one of the first checks into North Vector Dynamics. This is an extremely important company, and Elliot mentioned them as well, to help us bridge the gap between what we're working on right now and our ambitions and focus on defense, especially in hypersonics. We'll be sharing a lot more about our investments in these companies in the coming months. We're also excited to announce additional investments for NordSpace in our infrastructure, $10 million investment in Phase 2 spaceport development that'll help us get orbital ready. We'll have more details on this investment announced in June, but it's one small step that'll get us one giant leap closer to orbit. We have another $8 million investment that we're going to be announcing later this month related to our advanced manufacturing for aerospace lab. More details coming May 2026. Now, it's not just about investing in companies or ourselves. It's also about investing in our future. And we've spent so much of our time and energy investing in students. And that includes bringing them to conferences like these, but really about writing direct checks to help them grow. We, at NordSpace, a lot of us have come from the student experience. As you heard Cyril mention, started robotics for space exploration ages ago. We've invested now over $200,000 into student teams building robots, satellites, rockets, student competitions of all kinds, and are going to continue to accelerate this more and more. Now, we all started somewhere, and like I said, this is where I started, bottom right, Lego robotics as a kid, and born and raised in Toronto, always wanted to be a part of Canada's future in space. I had ideas and understandings about where Canada was in space, and some of them were correct, a lot of them were not. And I took it upon myself to bridge that gap and build the future that I believe Canada should have in space. Build robots, satellites, rockets, all kinds of cool things. But it's not just me. We have a team, and General Horner and Cody Pelletier visited us and met a couple of the members of our team seen here, just a few. Our team is now at about 30 people, and we're working extremely hard to get to 60 people by the end of this year. No doubt we'll get there. But these people also have incredible stories, including their technical backgrounds. We have over 200 years of space experience and rapidly growing, bringing experience from companies like MDA and Rocket Lab and SpaceX and SFL and Magellan and JPL and everything else you can imagine. And we're constantly investing in our people. Real technical depth, real technical breadth. Talent development, attraction, and growth are really important for us as well, and we're working on programs that allow interns and young engineers to quickly upskill and join our orbital scale programs. But these are all real people and humans. I've seen our team miss birthdays and anniversaries, sleep under desks and in shipping containers, work evenings, work late nights, days where our office hasn't closed for a whole week because people are sleeping on couches and in the field, working weekends. This is the only way, for better or for worse, to make something so ambitious happen at this grassroots level. And this is exactly the way companies like Rocket Lab and SpaceX achieved their success, not by 9 to 5 and phoning this in with remote employees and people spread across the country and the world. These are people working in our facility, making real technical progress happen and sacrificing everything to do so. So when I look at this picture again and I wonder, do we have the right stuff to achieve what these two companies did 10 and 20 years ago? I believe we do. And the gaps that do exist, we're always looking to fill them. And they're not just technical gaps, they're cultural gaps and systemic gaps that exist, and we'll have our challenges. We'll have our failures and successes, and we'll learn from all of them. But we'll have the resilience to actually accomplish what we believe is important for Canada and for our future. I'm going to end with a vision of what I believe Canada's future in space can look like. And I've tried to scope this vision and scale it down to what we can achieve over the next 25 years in Canada with, say, $250 million or so of investment every single year. What is possible? Because the thing that I think is missing the most, when I go to international conferences, when I go around the world or even in Canada, and people ask me, great, Colonel Jeremy Hansen flew around the moon. Huge, incredible achievement. What's next? Where are we today and where are we going? And I have no answer. I look to you for that. This isn't something that we should be defining. But in the absence of that, here's our vision. 2027, we put our stake in the ground. We put our flag in the ground, however small it is, on the surface of the moon. Canada belongs on the surface of the moon. One small step for NordSpace, a giant leap for Canada. 2033, we make our first interplanetary mission, decades overdue, come true. We have precedent for this. Payloads in the 100-kilogram class, 200-kilogram class. Venus is our next-door neighbor. Easy mission. We're working with Professor Jason Rabinovich, who actually is giving a talk on our Venus mission concept. And we can make this happen. We have the technology and we have the capabilities. 2036, let's get a Canadian astronaut in space. And this isn't something that we have to build entirely ourselves. In fact, it's highly likely that we won't be able to. But commercial manned spaceflight companies are progressing at an incredible clip, and we can do this and play a substantial role where we internalize the knowledge and then adapt it and build and stand on our own 2 feet the way we are now with launch. 2037, let's get a Mars rover. No more piggybacking payloads on other people's rovers and other countries' rovers. We can do this. Companies and countries have done this for decades. This is very much within our capability set. 2040, 15 years from now, small space station called Alouette. Send our first astronauts to our Canadian space station, whether Canadarm and whatever else you want to stick on it, but it's a Canadian space station, Canadian astronauts launching from Canadian soil. 2043, this can honestly happen way sooner. First sample return mission. Again, huge historical precedent for this. All the technical capabilities, all the talent available. There's absolutely no reason we can't do something like this. And 2045, we plant the Canadian flag on the moon with a Canadian astronaut in a Canadian capsule. I sure hope it happens before that, but being able to do that on our own terms is when we regain our place as a leader in space, the third country with Alouette 1 to place a satellite in orbit, not on our own launch vehicle, unfortunately, but still a statement to the world that Canada is there. We're in space. And by 2050, we become an essential part of humanity's exploration in space. We have our flag everywhere, deep space, Mars, wherever, we're there. Now, this might sound like a far-fetched vision, and I remind you that this is a 25-year vision, and I remind you to look at countries like China and India and others that have achieved so much in so little time. There's absolutely no reason with the history, the talent, culture, and the capability that we have in Canada that we can't do the same thing. We just need the vision. So my question for you is very simple. As always, will Canada choose to be a leader or participant? This is a conscious choice we can make today. We choose to be leaders. I believe everybody here chooses to be leaders, but we have to be intentional, we have to be focused, we have to be ambitious, and we have to put the right pieces in place today that bring us that future tomorrow. So thank you very much for your time and for being here at the conference, and I hope you enjoy the rest of the evening.